All right, welcome back. So now we're going to talk about transformations. Transformation applied. We learned it. Think back, we did our Desmos class activity, and that I think we found very helpful to visualize. And so feel free to just have Desmos out and just manipulate it and see what happens to it. We might do that at the end of this video. But if you're given a function f of x, the transformation that can be applied is a times f of bx minus h plus k. A lot is happening here, but all this boils down to is translations, shifts, we have stretches and compressions, and we have reflections. So these three types. And there's a certain order that we need to keep in mind as we do these. So first off, we have horizontal shifts by h divided by b units. H is over here, b is over here. Next, you do any stretch or compression. So your a's and your b's. And in any reflection. Reflections aren't shown in this example. This kind of fake formula that we have. Honestly, 2 and 3, stretches, compressions, and reflections can all be done at any point. You can do reflections before stretches, before compressions. But I'm just giving it a definite order so that we aren't confused and there's a lot to keep track of. And finally, we can do vertical shifts. So let's take a stab at something. So let's say f of x is equal to 1/2 absolute value of negative x plus 2 minus 1. There's a lot going on here. 4 transformations, which is more than what we've kind of been doing. Think back to our homeworks, our quizzes, our tests. I did upload a big doc of everything that I have downloaded on my work laptop. It's not everything, but it's probably helpful. And step 1 is we want to list our transformations. Very similar to inverse functions, you want to list everything so that you keep track of it. And let's list it in order. So I see, do I have a horizontal shift? And I see, yes. My thing is a horizontal shift. My h in this function, h equals -2. My k is -1. My b is actually just 1. And my a is 1/2. Let's touch on this real quick. My b is 1 because b and a will always be positive. That's something you want to keep track of because the negatives are just reflections. So let's keep track of reflections, and we see we have a negative right here. So if b is negative in this case, but it's actually positive, the negative being there means that I have a reflection. And we'll touch on a reflection as we get to step 3. But for horizontal shifts, h divided by b units. -2 divided by 1 units. If it's a negative in my horizontal, then it must be going 2 units left. Next up, number 2. Any stretches or compressions? A is 1/2. So a vertical compression by a factor of 1/2. And now we see any reflections. I have a negative inside close to my x. So therefore this is a reflection across the y-axis. And now finally vertical shifts. My k is -1. So I have a vertical shift down 1 unit. A lot is happening. But with all these shifts, with all of it written down, we can now draw my axes and label our parent function and apply it one by one. So my parent function in this case is the absolute value of x. And parent function starts just like this. Parent function right here. And then we shift 2 units left. So I move 2 units left, and I shifted it. And let's actually make this, we'll change colors as we go. We'll make it, the first one red. 2 units left. Next up, vertical compression. So red is this one. Next up, vertical compression by a factor of 1/2, which I'll make blue. So vertical compression, it kind of goes flatter. Next, we see a reflection across the y-axis. And that's something we need to kind of keep close in mind, which I'll make green. So I'm going to go across the y-axis. So this is my point of my axis of reflection. So I'm at -2, so I must now go to +2. Then we vertical shift down 1 unit. And now finally with this, I'm going to put it back to a new line, new graph. So it was at +2, and I shift down 1. So my graph will be just like here. I did my shift to the left. I compressed it, reflected it, down 1. And this is your final graph. And we want to plot some points. The starting point is easy to keep track of. We went left 2, reflects, so I'm at +2, then down 1. So I'm at 2, -1. And the good thing about this is we can always plug into, like, you can keep track of other points, but also just plug into my parent function. Which points do you think might work? With absolute value, it's pretty fair to us. Like square root, cube root, honestly squaring and cubing as well. And rationals, those are kind of rough. Like there's a chance you get like a weird decimal or an answer doesn't exist. But let's plug in 0. 0 plus 2 is 2. Absolute value of 2 is +2. Times 1/2 is 1. Minus 1 is 0. And we see my graph does hit through 0, 0. So 0, 0 is another point. And let's say if I have 4. Actually, let's choose one that I know is not as nice, 3. So plugging in 3, -3 plus 2, 1/2 minus 1. So -1 as a value. It has to be a +1. So +1/2, like 1 minus 1. 1/2 minus 1 gives me -1/2. And that's, knowing where -1/2 is kind of fine for us. So over here, I'm at 3, -1/2. So these are our transformations. So taking a look over here, I should change it to be reverse contrast. We see that our graphs, it did line up perfectly. And let's actually just change it. So I have A times absolute value of bx minus h plus k. Add sliders to them all. Set these to 0 first, and these to 1. I also mess around with it. See, like, as I am stretching, as I'm compressing, and also as I reflect, what happens? So, like, as you practice, as the value is the easiest one to practice, honestly, square root, squaring, you could change this real quick to be like, I want to actually change this to be a square. And see, how does this impact my graph? You could pick a random one with some clean numbers, be like, and like try doing like maybe 2 or 3 at a time. Like a negative counts as a 1 as well. So -1, 2, and like a horizontal shift 1. And see, can I graph this? Like, pick those numbers, plug those in, write it out, and see, did you get it correct? If I have rewriting this as -1 or negative 2x minus 1 squared, can I see, oh, I have an h value of 1, so I'm shifting 1/2. Since it's a negative, I'm shifting it to the right 1/2. I'm then doing my compression, my horizontal compression, which is something I want to also point out as well. Horizontal compressions is 1/b. You compress by 1/b, not just by b. That is in a textbook. That should be in our notes. So the horizontal ones are a bit rough. Horizontal shift by h/b. You could like stick absolute values to it if you want. And horizontal compress and horizontal stretch by 1/absolute value b. And vertical shift by k. Vertical stretch by absolute value of a. Because a and b we want to keep positive. Going back over here, you see that I wanted, I think this works. R is shift 1/2. We said that since it's negative, it must be to the right. We want to R is compress by 1/2 as well. It's just by chance that this is 1. So we have 1/2 and 1 divided by b. So you have 1/2. We want to reflect over the x-axis because the negative's on the outside this time. And these are my 3 transformations. So we see, is that happening? Yeah, we see it. I did shift over to the right. I did compress it. So it's a lot skinnier. Whereas if it wasn't there, it's kind of fatter. It's skinnier, it's compressed. And it did reflect over the x-axis. So do some, make your own problems, and see, can I do these graphs? No, that was surprisingly short. But yeah, once again, good luck with studying. As I said in my note, please make sure you take care of yourself. Eat well, sleep well. And honestly, like, after, maybe in between, I think math is the afternoon. In between your 3rd and 4th exam, just like go out with a friend, like grab, I don't know what's nearby here, but like, I don't know, grab an ice cream or like just take a walk or just like rest for a bit. And then, because I know break starts in like a day for you, but like after exam, but still just make sure you take care of yourself during that time. And then take yourself well enough so that you can kind of focus up for extended period of times. It is not great, but like you will have to practice the skill in college. You will have to practice taking like 5 exams in like 2 days, and like there's no accommodations because some professors care, but most kind of don't. And you kind of just like dial in and lock in for like 40 hours straight. But make sure you take breaks, take care of yourself, and good luck studying.